Myself, Vinodhini, and my team member is Monica. We are from Tech High Tech Engineering College. Our final project is detection of indiscriminate spoofing attacks in wireless networks. Detecting the multiple attackers, that is spoofers, in wireless network is the main aim of our project. Now, let us see the basic spoofing, that is IP spoofing. IP spoofing is a trick played on servers to fool the target computers into thinking that it is receiving data from source other than the trusted host. IP spoofing is a technique used to gain unauthorized access to computers. Now, let us look at an example for IP spoofing. A is speaking to C, but C is thinking that B is on the line. A is discussing his voice, making it sound more like that of B. If we now replace the three people by computers and change the term voice with IP address, then you would know what we mean by IP spoofing. Now the objective of our project is mainly to avoid the unauthorized and spoofing attacks in all the security fields. Abstract. Wireless spoofing attacks are easy to launch and can significantly impact the performance of networks. The identity of a node can be verified through cryptographic authentication. IP spoofing can evade detection and put a substantial burden on the destination network for policing attack packets from the attackers. In this project, we propose an interdomain packet filter architecture that can mitigate the level of IP spoofing on the network. IDPFs are constructed from the information implicit in border gateway protocol, route updates, and are deployed in network border routes. Existing system is ingress and egress filtering. In ingress, an ISP, that is Internet Service Provider, provides receiving from its stub connected networks packets whose source address does not belong to the corresponding stub network address space. Egress is a router or a firewall, which is the gateway of a stub network, filters out any packet whose source address does not belong to the network address space. And the proposed system is interdomain packet filters, a system that can be constructed solely based on the locally exchanged BGP updates. Each node only selects and propagates to neighbors based on two sets of routing policies. They are import and export routing policies. The IDPF uses a feasible path from source node to the destination node, and a packet can reach to the destination through one of its upstream neighbors. Now this is the architecture diagram. That is a sender and a receiver. There are some nodes in between the sender and the receiver, and they are the routes to transmit the messages and to receive the messages. But if any intruder comes in between the transmission, the node will block the way the message has to be transmitted to the receiver, and the neighbor node will send the message through another neighbor node, or it will change the route path. For example, the message is transferred from sender through N1, N2 and receiver. There are several paths in this IDPF, and now sender sends the message through N3, N4 and to the receiver. Now the intruder comes in between the N4 and the receiver. Now the message does not pass through N3 to N4. It will pass through to N3 to N2 and to the receiver. This is the main architecture of our project. And the modules are construction of nodes, finding feasible paths, constructing interdomain packet filters, and detecting and blocking the intruder. As we know, construction of nodes is constructing of multiple nodes in between the sender and the receiver. And wireless networks, classes that provide automatic reconfiguration of access points, adjusting power levels and channel assignments to optimize coverage while minimizing contention between neighbors. The RSS readings over time from the same physical location will belong to the same cluster point in the n-dimensional signal space. And the next module is finding feasible path. The sender will find the feasible path to transmit the message to the receiver. Converting a large dataset into the medium format for the computation purpose, received signal strength indicator formula, the RSS stream of a node identity, may be mixed with RSS readings of both the original node as well as the spoofing nodes from different physical locations. And the next one is constructing interdomain packet filters. The cluster algorithms cannot tell the difference between real RSS clusters formed by attackers at different positions and fake RSS clusters caused by outliers and variations of the signal strength. The minimum distance between two clusters is large, indicating that the clusters are from different physical locations. And the last module is detecting and blocking the intruder. When the intruder is identified using the IDPF filters, the intermediate node will block the path and change the path to reach the destination, as we showed in the architecture diagram. And the next one was system design. This is the first level of a project. The sender will transmit the selected destination IP. It will set the destination IP and it will search the node, which node is feasible to transmit the message, and the node will be selected. And the next level was the message will be entered and the route will be selected, and the message will be transmitted through encryption, and if the data is valid it will pass through the intermediates, and as well as decryption with data verification, and the receiver will get the message. And the last one was level 3 was when the intruder interferes in it. Yes, selecting the route and sending the message. As we know, encryption and then passing through intermediates. And if passing through the intermediates, that is when the message is passing through the nodes, the spoofing attack was introduced. If the spoofer was introduced and the attacker is detected and finding an alternate route, and then through that alternate route the message is transmitted through the receiver. Transmitted to the receiver with the decryption. And the next one was our projects. As we know, the sender will select the destination to which location it should send. Then it will find the destination IP and then the available nodes. Yeah, as you see in the first sender dialog box, that will be a destination, and the destination IP will be fetched by the sender, and there are some available nodes, and then after the available nodes the sender will select any one of the available routes, and the message is sended, and then there are lot of intermediates, that is nodes. After the message is successfully sent, there will be a alert message, and then the receiver will get a receiver message also will be displayed in the sender. Yeah, if there is an intruder in between, we have implemented into .NET and we have created an intruder, and there is a spoofer we have found, we have detected it. After the spoofer is identified, it will give an alert message that intruder found, and the sender have chosen another path, that is the intermediate have chosen the another path. Yeah, in our project the intruder or spoofer cannot able to enter to the network group. If the intruder enters, the pathway is changed and attacker is blocked. Our project can also be implemented in wired networks and wireless. It can able to identify number of attackers. Thank you.